Have you ever wondered what it would be like to vanish from one location and instantaneously appear in another? This is the tantalizing premise of teleportation, a concept that has captivated our imaginations for generations. From the teleporting transporter of Star Trek to the jaunting humans in Alfred Bester's The Stars. My destination, teleportation, has been a staple in science fiction. But is it purely the stuff of fantasy? In reality, this idea has sparked curiosity among scientists for decades. They've delved into the mysteries of quantum mechanics, a realm where particles can exist in multiple places at the same time. Theoretical physicists and quantum scientists have even achieved teleportation on a tiny scale with particles, hinting that this sci-fi concept might be grounded in scientific fact after all. So, teleportation might not be as far-fetched as it seems, but how does it theoretically work? Stay tuned as we unravel this mystery in the next scene. Quantum mechanics, the field that studies the smallest particles in the universe, has given us a theoretical basis for teleportation. This theory rests on a peculiar phenomenon known as quantum entanglement. To put it simply, quantum entanglement is a strange but scientifically proven occurrence where two particles, no matter how far apart they are, can be linked in such a way that the state of one directly influences the state of the other. Now, imagine if we could harness this phenomenon to teleport things. In essence, we'd create a pair of entangled particles, separate them, and then use the state of one to determine the state of the other, effectively teleporting information from one place to another. Sounds like science fiction, right? Yet, in the world of quantum mechanics, this is not only possible, but it has actually been done. Scientists have successfully teleported information between particles over small distances. These experiments are a significant stride towards understanding and potentially utilizing quantum teleportation. But it's crucial to note that they've only teleported information, not matter. Teleporting something as complex as a human being is a leap of a completely different magnitude. The sheer number of particles that make up a human body, and the intricacy of their interactions, make this a daunting task. However, teleporting humans is a whole different story. Why is that? Theoretically, teleporting a human would require a precise scan of all the person's atoms, then using that information to reconstruct the person elsewhere. But here's where we hit our first big snag: the Heisenberg uncertainty principle. This quantum rule suggests that it's impossible to simultaneously know the exact position and momentum of a particle. This makes the detailed scan we need for teleportation a real head-scratcher. Now let's say we could bypass the Heisenberg hurdle. We're faced with another conundrum: the ethics of it all. Teleportation, in essence, involves destroying a person at one location and reassembling them at another. This raises a host of questions. Is the teleported person the same individual or a new one? Are we killing one person to create another? The challenges are significant, but imagine the possibilities if we could overcome them. If teleportation were possible, it would revolutionize the way we live. Imagine a world where distance is irrelevant, transportation instant, traffic jams, delayed flights, long commutes, all obsolete. Commerce would thrive, with goods reaching customers in the blink of an eye. But this new world would not be without its challenges. Privacy concerns, security risks, and societal upheaval could follow. Teleportation, a fascinating concept that encapsulates the thrill and mystery of scientific exploration. One can only wonder, what if?